Okay, so as it is already time is over, so we'll start our today's session without wasting much of your time. So good morning and welcome to second year. And here we are going to see the course that is the chemistry of fiber 1. Now, whatever this particular course it is there, see if you refer the old syllabus, in old syllabus, this course was in the first year, second sem, but we have revised the syllabus content, and from second year onwards, you are going to study the actual textile part. It is no doubt whatever the things which you have studied in the first year, they are based for all these particular things. Whatever the chemistry of fiber 1, 2, which you are going to study, as well as whatever the polymer science subject we are going to study, whatever the pre-treatment subject it is, there's the base for this, whatever the prerequisites for the particular course it is there, you are going to study in a already you have studied in a chemistry of fiber 1, in a first year. Now, regarding whatever the chemistry of fiber 1, now the basic information which is required. So you have studied the organic chemistry. So organic chemistry 1, organic chemistry 2, whatever the content it is there, that content will help us in this course, as well as some part of the inorganic as well as the physical chemistry also going to help us. So that will be the best for our course it is there. Now, whenever you are talking regarding the chemistry of fiber 1, so here, if you see the details regarding the chemistry of fiber 1 theory part, it is there. See, we got total 3 lectures per hour, and credits are 3 it is there for the theory. As per the examination is concerned, SC1 is of the 25 marks, SC2 is of again 25 marks, SE, see though that might be of the 80 marks, 60 mark or the 100 mark it is there, but finally we are going to convert it to the 50 marks, and likewise total will be 100 marks will be there. Sorry, just so final will be of the 100 marks will be there. So likewise total 3 hours and 100 marks it is there. Now regarding the course outcome, so there are total 4 outcomes are there. Now if you see the syllabus, in all the courses, see the course is nothing but our subject it is there, and program is nothing but our textile chemistry. So in textile chemistry program, what are the various courses which you are going to study? There are 4 course outcomes are there in every course. You just check it, or you already seen in a first year also. Means what does it indicate? See, whatever these course outcomes are there, see the meaning of this course outcome. See, at the end of this particular subject means course, you will be in a position to first describe the basic concept of the textile fibers. You will be in a position to describe the morphological and the chemical structure of the natural fiber. You will be in a position to enunciate the physical, mechanical, chemical properties as well as the applications of the various fibers. And last, that is nothing but you will be in a position to describe the concept of the various spinning technologies and the fiber manufacturing processes over there. Is after completion of the course, see, not at first our SC1 or after the SC2. I'm talking about overall at the end of the course. So all these 4 things you are going to get, that is nothing but the outcome of this particular course. See, even same outcome we got the for the practical also. Now coming to the course content which you are going to study over here. Now you can check the content from the syllabus also. Now also I'm going to just give you the brief idea regarding the what are the things we are going to study in this course. So as you have studied basic things in the first year, so this is the first subject which you are going to study as per the textiles is concerned, that is nothing but the chemistry of fiber 1. So first, that is the introduction part will be there, where you are going to study the concept of the fiber, yarn, fabric, staple fiber, filament, degree of polymerization, cohesive energy density. So these are the small things, but these are the basic things which we must know whenever you are going to study the textile in detail. Means what does mean by the fiber, yarn, fabric, staple fiber, filament, degree of polymerization, cohesive energy density. Then we are going to study the classification of fiber according to their chemical nature and the origin. Now, whatever the based on to the classification only, there are so many practicals are there. I think someone's mic is on. Just check. Yes, someone's mic is on. Just inform him. Kamesh. Hmm, Okay. Sorry for the disturbance. Okay. Then next point that we are going to study the classification of fibers according to their chemical nature and the origin that we are going to see in detail. Now see whatever the part related to the classification of fiber according to the nature and the origin which you are going to study, it is there. So based on this also we are going to perform few practical, that is identification of fibers. So that's why this point is there for us. Now whatever our theory it is, is theory and the practically will go hand in hand. Means whatever the part which you are going to study in the theory, it is there based on this part only the practicals are there. And next, that will come to know when we are going to study the details regarding the practical. Next, that is the essential and the desirable properties of fiber. That is our next point. Though this is a small point, but this is a one sentence point, but there are so many things are there. Various essential, just like five different essential properties, four different desirable properties that we are going to see. Means again we are going to see what is the essential, what is the desirable. Can anyone will tell me essential and the desirable difference? Yes, any one of you? I don't want to be a good listener. Yes, any one of you? What is the difference between essential and the desirable properties of fiber? Yes. Am I audible to you?
Yes, sir.
Yes, sir.
Okay.
Sir, essential
If I am
property.
audible, yes.
Sir, am I audible?
Yes, you are audible. Yes.
Sir,
Yes, Sujay.
essential property, length and length variation, then strength of fiber, then uniformity.
No. I just
Uh,
need the difference between essential and the desirable. Yeah, whatever you are telling that is correct, but that is related to the fiber. I need in general statement.
sir, it's physical properties and
No, no. See,
Hello,
essential
sir.
means that. Yes, yes.
Sir,
Any one of
essential means which are important.
which are important and desirable means
Which are
which
important but
requirement.
not compulsory.
which are yes, my three. Yes, you are up to the point. Yes,
But
what
which
you
is
are
not
told,
compulsory.
which is not
Essential
compulsory.
means which is important and desirable
Yes,
means which is not compulsory but
yes.
we are used it.
Yes. See, Sujay and Maitri, your both answers are correct. Now, see, essential means the things which are mandatory. I mean, that particular fiber must possess this property or any of these things must possess. For example, see, when you want to take the admission to the degree, means you must be in a 12th. And essentially that minimum, whatever the criteria, 45% was given to you. That is essential. If you are not fulfilling that, You will not be in a position to get it. You will not get the admission. Desirable means, see, even if you got the lower mark in a CET, that doesn't matter. If you got a higher mark, that is well and good. If you got a lower marks, that is a not good. It is there. Means essential means which is a mandatory to all. And desirable means if these properties are present over there, or these are the criteria, if they are present over there, it will give the additional benefits to everyone. Hmm? So that's the difference between essential and the desirable properties of fiber. Next, that is a concept of the crystalline region, amorphous region, mesomorphous region, and their importance. Hmm? These points. Along with that, one more point that we are going to study, that is nothing but related to the moisture it is there. Hmm? So it will come under this any of this point, but separately we are going to study in detail regarding this. So these things we are going to study in unit 1. Then in unit 2, we are going to study the natural cellulosic fiber, that is nothing but the cotton fiber, which we are regarding as a king of the fiber it is there, and which is the most commonly used fiber all over the globe. So first point, that cultivation of cotton and the varieties of cotton, that point we are going to see. Then next point, that is a morphological structure and chemical composition of the cotton fiber. Morphological structure means in detail. See, if you take the any of the fiber, see what is there in this particular fiber in a physical form, means what is there in outermost layer, what is there in the innermost layer, how the things are there inside the fibers, that we are going to study. Then chemical composition. Chemical composition means which are the components are present over there. For example, in case of cotton, we are going to study the how much is the cellulose, oil, fat, wax, moisture, ash content, all these things, pectins, all these things we are going to study. Next, that is the chemical structure of cotton. Now, always there is a misconception between the chemical composition and the chemical structure. Chemical composition means what are the things over there, and chemical structure means how this particular polymer it is there. Now, cotton is a cellulosic fiber. It means there will be the cellulose structure in detail we are going to study. Next point, that is a chemistry of cellulose. We are going to study in detail, means what are the things are there in a cellulose, that we are going to see. Next, structure and the reactions of cellulose. How the structure of the cellulose it is there, various type of the reactions of the cellulose. See, though this is a part is there in a cotton it is there, but these things are applicable to our third unit also, related to the reactions of the cellulose. Fourth unit also means wherever you are going to study the cellulosic fiber fabrics, these things is there, means whatever the D point, E point will be there. Even in jute, flax, we are going to get, even in a viscose yarn, we are going to get, in acetate also we are going to get, which reactions of the cellulose. So just like oxycellulose formation, hydrocellulose formation, all these things we are going to study. And last point, that is a physical, mechanical, and chemical properties and applications of cotton fiber we are going to study. Then in unit 3, that is unconventional natural fiber. Unconventional means the fibers which are most not that much commonly used, but they got the importance over there. For example, morphological structure and the chemical concentration of the jute and the flax fiber we are going to study. So here we are going to study the two fibers, jute fiber and the flax fiber. Jute, every one of you are aware. Flax, that in that you might be heard the term linen. Have you heard the word linen? So linen is a fabric, flax is a fiber, it is there. So that fiber now is getting a tremendous demand in a market. That's why we are going to study this fiber also. Next, that is a concept of the hemicellulose, lignin, and their chemistry we are going to study. Already we have studied the chemistry of cellulose. That's why we are not repeating this point over here. Otherwise, there will be the concept of the cellulose, hemicellulose, and the lignin. It is there. But cellulose, as we have studied earlier, that's why this point we are not going to repeating. Next point, that is nothing but the rating and the extraction of jute and the flax fiber. Means how we are going to get the jute fiber and the flax fiber in detail we are going to study. Then last point, again, physical, mechanical, chemical properties of fiber and applications of fibers, that is jute and flax. The next point, that is nothing but the regenerated cellulosic fibers. Regenerated means regeneration, means one form we are going to convert into the another form. One form of the cellulose we are going to convert into the another form of the cellulose. That point we are going to see over here. So first, that is a concept and the essential requirements of the wave spinning that we are going to see. Second, we are going to see the concept of extrusion and the spinning. Now, what is the difference between the extrusion and spinning, that we are going to see. Now, concept and the essential requirement of the wave spinning. So what is the wave spinning and all these things also we are going to study. See the spinning technology. I think you are studying one more subject, spinning technology. The spinning technology which you are going to study over there, and the wet spinning, dry spinning, which you are going to study over here, they are completely different. Means wet spinning, from the carrying out the wet spinning and the dry spinning, we are going to get the filaments of the fibers, and that whatever end product of the wet spinning and the dry spinning, whatever we are going to get in a fiber or the filament form, we are going to convert into the yarn form, and that process is nothing but the spinning it is there. So whatever the wet spinning and the dry spinning it is there, generally they are called that extrusion process, where the conversion of these fibers into the yarn, that is called a spinning process. So how these things are there, that we'll study while studying this point. Next point, that is the theory of solidification of polymer in a wet spinning. Means how the whatever the polymer solution it is there, it get convert into the filament form or the fiber form, that we are going to study. The next point, that we are going to study the raw material manufacturing process of the three fibers that are nothing but the viscose rayon, polynogic rayon, and the tensile fiber, tensile or the lyocell. Regarding this fiber, we are going to study. Then next point, that is the physical, mechanical, chemical properties and applications of these three fibers, that is the viscose rayon, polynogic rayon, and tensile fiber we are going to study. The next, in a unit 5, we are going to study the modified cellulose fibers. Means what is a modification we are going to do, that things we will study over there. So here we are going to study the concept and the essential requirements of the dry spinning. So what is the dry spinning, how it is carried out, that all these things we will study. Next, that is a theory of solidification of polymer in a dry spinning, that we are going to study. Next point, the raw materials required, manufacturing process of the cellulose acetate. So what are the various raw material, how we are going to procure it is there, how we are going to convert this raw material into the modified cellulosic fiber, that is nothing but the cellulose acetate, that we are going to study. And next point, that is nothing but the physical properties, mechanical and chemical properties and applications of the cellulose acetate fiber. Then last unit, that is a animal protein fiber, in which we are going to study the two fibers again. So first, in that, in general, we are going to study the chemistry of protein and the amino acids. Then actually, I think this point is not covered in your first year, but around within a 1 hour, we try to complete this. What is a protein integer? What are the various type of the amino acids? Because that is the base for this particular unit. That's why we are going to take this point, that chemistry of protein and the amino acids. Then types and the gradings of the wool. So what are the various types and the gradings we are going to get in wool, that we are going to study. Next, morphological structure, chemical composition and the chemical structure of the wool fiber we are going to study. That is a just like I told you, what will be there in a fiber, we are going to study in detail. What are the various constituents of the fiber, that, and the chemical structure, what is there, that we are doing. Just like chemical composition, I'll tell you example, that we got the protein, keratin, then sweet, we got the soil, moisture is there, oil fat waxes are there. So all these things we are going to study. And chemical structure, we are going to study the details regarding whatever this protein and how the structure it is there, that is a polypeptide chain Hmm? What are the various type of the amino acids? That point we are going to study. Next point that we are going to study the various type of the bonds present in a wool fiber. So just like we got the hydrogen bond, salt linkages are there. Hmm? Then we got the our cysteine linkage. All this we are going to study. And last, that is a physical properties, mechanical, chemical, and properties and applications of the wool fiber. Then next, we are going to study the details regarding the types and the production of the silk. We are going to study. So what are the various varieties instead of the types, that is called as varieties of the silk, production of the silk, then morphological structure, chemical composition, and chemical structure of the silk fiber we are going to study. And last point, that is nothing but the physical, mechanical, and chemical properties and the applications of the silk. Hmm? So likewise, we are going to study the all these six fibers. Now, if you study the overall content, see what is there overall means morphological structure is there, chemical composition is there, chemical structure is there, physical, chemical, mechanical properties and applications are there, hmm? And types and the we can say the various varieties of the fiber. So these are the common points which are present in all the fibers. Hmm? Then next, in short, I will tell you regarding the practical, and during the practical hour, again, we are going to see this point. So the course code for the practical course, that is a chemistry of fibers 1, that is a TCP 237 is there, chemistry of fiber 1 lab. Practical hour, we got the 2 hours, credit is 1. CI 50 marks, there is means term work is there, there is no practical examination, but But see, listen carefully. Whatever the practicals which are going to perform in chemistry of fiber 1, some of this particular practical will be there for the practical examination which we got in chemistry of fiber 2. Hmm? Clear the point? Means whatever the practical, some of the practicals are there in a chemistry of fiber 1, that will be there in a chemistry of fiber 2 lab. Means whatever the chemistry of fiber 2 practical examination it is there, it is a combination of practicals of chemistry of fiber 1 and fiber 2. Clear? Then term works are allotted by the continuous monitoring during the lab work. And submission is nothing but the completed journal it is there. And this is a list of the practicals which I will tell you during the our practical hours, which you are going to see. So there are total 12 practicals are there, and one by one we are going to complete all these practicals. Okay, so this is regarding our content it is there. Any doubt regarding this point or the content or the regarding the chemistry of fiber 1? Now we are going to start with our actual syllabus content. Yes. Any doubt regarding this point? If there is no doubt, we'll proceed. Okay. Okay. Can you see the presentation? Any one of you? Just
sir.
give me a.
Yes, sir.
Okay.
Yes, yes, sir.
Okay. So now we are going to start with our actual syllabus content. That is nothing but the introduction to textiles or whatever our first unit it is there. That is the introduction to textiles. Okay. So what are the first point which was there in our syllabus? That in the concept of the fibers, yarn, fabric, staple fiber, filament, degree of polymerization, cohesive energy density. That point we are going to see over here. Now see, whenever we are using the term as a fiber, hmm, okay, so it is a basic raw material which is used for the, see there are various definitions are there. If you refer the various books over there, various authors, they have given the various definitions over there. You can refer that also. So it is a raw material which is used in a textile manufacturing. Now see, whatever the yarn, fabric, the terms which are here or the you are seen over there, see whatever the basic raw material which are using for the manufacturing of these things or in a textile industry, that is nothing but our fiber it is there. Now whatever the fiber it is there, fiber we can have it into the different forms also. We can have it into the short staple fiber. Likewise, you can see over here. Hmm, these are the short staple fibers are there. Even if you see this thing that is a cotton under the microscope, it is there. This is also fiber, it is there. Hmm, can you see this? You need to understand this point because this is the basic things are there. Hmm, so it is a raw material which is used in a textile manufacturing, or another definition that it is a basic raw material which can be converted into the yarn or the fabric. Means from this, so whatever the fibers are there, for example, these are the short fibers are there. Hmm, this is a filament, it is there, or the individual filament. If you take into consideration from this, what we are going to do, we are going to convert it into the yarn or the fabric form, it is there. Means from the fiber, either we can have it into the yarn form, or these fibers we can convert to the fabric also. That is also possible. No need to convert it into the yarn form directly. Whatever these fibers are there, these fibers we can take and we can convert these fibers into the fabric form, that is called that non-woven fabric. Hmm. So right now, whatever the mask which you are using, it is there. Hmm, mask which is made from the non-woven fabric, it is there, or various type of the wipes which are using, it is there. So this is the non-woven fabric, it is there, which we are converting from fiber to the fabric. No need to convert to the yarn. So whatever the intermediate step it is there, that intermediate step is not there in case of the non-woven. So directly fibers we can convert to the yarn form, it is there. Now whatever the fibers are there, these fibers we can have the natural fibers, we can have the regenerated, we can have the synthetic fibers also over there, or we can have this fiber into the filament form also. See the fibers, there are two types. One that is a short fiber and another that is a continuous filament. So can you see the pictures over here? So this is a fiber, these two, and these are the filament, it is there. So short fiber, they got the definite length is there. Means for example, when you are going to take into consideration the fiber, short staple fiber, you see this much length or this much or this much also. Hmm? So there's a variation, it is there. So mostly whatever the natural fibers which are going to get it, natural fibers we are going to get into the short staple fiber. Got a point? In natural fiber we are going to get into the short staple fiber. Except silk, silk we got the continuous filament. Other than the silk, whatever the fibers naturally, that might be a cellulosic or the proteinous one, it is there, we are going to get into the short staple fiber. Whereas whatever the regenerated and the synthetic, or we can say the man-made fibers are there, these man-made fibers we can have it into the continuous filament form. So whatever the length it is there, this length will be in the thousands of the meter. Means in a kilometer we are going to get it. Whereas here we got few mm. Hmm, 45 mm, 55 mm, 50 mm, 60 mm, 70 mm. We can suppose if the proteinous fiber, just like if we got the wool or yak or the camel, rabbit hair, where we can go near about 300 mm also. Means 1 feet. Likewise, but length is the short it is there. Another definition technically which you are using, that is nothing but it is a high molecular weight interaction product of the polyfunctional species. So it is a high molecular weight product. So how we are going to get high molecular product? What is the interaction? And polyfunctional means either there will be the various type of the groups are there. So based on this particularly the groups, just like in case of the cellulosic fiber, we got the hydroxyl groups are there. In case of the proteinous fiber, we got the hydroxyl, carboxyl, amine groups. Likewise, the various groups are there in fibers. It is there. If you take into consideration the nylon fiber, we got the carboxyl group and the NH2 group, that is the amine group is there. If you take into consideration the polyester, we got the carboxyl and the hydroxyl group, it is there. Means various type of the functional groups are there based on the what type of the fiber is there. So it is a high molecular weight interaction product of the polyfunctional species. Clear the definition of the fiber? Any one of you? Any doubt?
Okay.
Yes?
No, sir.
See, there must be an interaction.
Yes, sir.
Clear? Okay. Then we'll move to the next slide. Now, next, that is nothing but the yarn it is there. Next thing, that is nothing but the yarn. So yarn is a continuous length formed by the twisting together the staple fibers of the several filaments over there. See, fiber means we got the basic raw material which you are using for the, sorry, means raw material which you are using for the converting into the yarn or fabric. Now we are concentrating on this point, that is nothing but the yarn it is there. And yarn we can have it from the short staple fiber or from the filament. Means whatever the yarn it is there, the yarn is a continuous length formed by the twisting together a staple fiber of the several filaments. Now a simple example I'll tell you. See, in home now, for the lamp, yeah, what we are doing, we are taking the cotton fibers and we are twisting it is there, so that we are going to get a continuous strand over there. See, nowadays for the lamp, what we are doing, we are taking the short staple fiber and we are twisting. We are spinning it is there. So in spinning, what we are doing, we are applying the pressure, we are applying the twist over there, so that whatever the fibers are there, see these fibers, they will get twist, and because of the twist, there will be the entanglement, and these fibers will get entangled with each other, giving us a continuous length over there. So yarn is a continuous length formed by the twisting together staple fibers or several filaments. Now this is the case with the filament. Now you can check over here, this is an individual filament, and when you are taking a bundle of filament together, we can have the yarn over there. Now there are different type of the yarns are there. So we are not going to details regarding the different type of the yarns. We are going to study in a spinning in detail. Now for example, spun yarn, in to have the spun yarn, again we are using the various type of the spinning technologies, just like a rotor it is there. We can have the carded yarn, we can have the combed yarn, we can have the compact yarn, but that is nothing but the open end of the ring spin yarn it is there. So open end of the ring spin yarn is mostly used for the short staple fiber, where the short staple fiber we are converting into the continuous yarn form. That is endless it is there. Depending upon our requirement, we can convert it into the required length. And next, that is nothing but from the filament. So whatever these filaments are there, these filaments we have to spin it, means we have to give the twist. And after the twisting, we are going to get the yarn over here. Now, this is just for additional information. See, not only these fibers, see, we can blend it with the conductive and the non-conductive fibers. We can have the conductive and the non-conductive filaments. We can have the coating. So these are the additional things that are just for the information it is there. But here we have to concentrate only on these 2 points. That is a spun yarn from the fibers, spun yarn from the filament it is there. Clear the point regarding the spun yarn? yarn rather than the spun yarn. Again, whenever we are coming practically one to one, I'll show you the where we have to use the term short staple fiber or this. See one more point. See whatever the filament synthetic fibers which I told you. See synthetic fibers out the rather than the man-made fibers. And man-made fibers we can have it into the continuous filament form as well as we can have it into the short staple fiber also. It doesn't mean that only whatever the man-made fibers will get the continuous filament. No, we can have this continuous filament into the yarn form, sorry, into the short staple fiber also. Depending upon our end use, we have to decide whether to convert it into the continuous filament or we have to convert into the short staple fiber. Means whatever the regenerated fiber or the synthetic fibers are there, these fibers we can convert it into the short staple fiber also. And from this short staple fiber, we can convert it into the yarn form. Now, what the advantage we are going to get it over there? See, whatever the you might be heard the blended fabric it is there or the blended yarn it is there. See, these blends we are going to get because of these short staple fibers only. For example, polyester cotton blend, where we are going to the polyester staple fibers, cotton staple fiber that we have to take it together. We have to carry out the spinning and we'll get a blended yarn. Hmm. Second example, polyester viscose, where, for example, we can have the uh, this polyester staple fibers. We can have the viscose staple fibers. See, both are the man-made fibers, but still, as depending upon end use, we are converting into the short staple fibers. And then these two fibers, we have to take it together and we can convert it into the blended yarn. That is the PV. Hmm? Polyester viscose. Short form is used PV, but actually it is a polyester viscose. It is there. Then next regarding the fabric it is there. So fabric is a product of interlacement or interlocking of yarn or fibers. See, three different terminologies. A fabric is a product of interlacing, interlocking of yarns, interlacing of yarns, interlocking of yarns, or it is a product of fibers of interlacing and the interlocking. When you are carrying out the interlacing, we are going to get the woven fabric. So in woven fabric, we can have the warp, we can have the weft. I will just, okay. So how it is carried out, there are 3 videos are there that I will show you. Now woven fabric, where we are going to carry out the interlacing, means for the interlacement, what is required? We require warp. So, sorry, warp, we got the continuous strand over here, which we got it from the beam. So another term which are using for the warp, that is nothing but we are using the term as a ends also, ENDA, huh? Ends. And next, whichever the traverse way is moving, that is nothing but the weft it is there. And at the end of the fabric, see if you take any fabric, at the end, there's one more thing it is there that is called a selvage. Have you seen the fabric? A complete with fabric, if you see, we got the selvage over here. That is a thick portion it is there. So whatever the warp it is there, the warp is running parallel to the selvage, whereas the weft is running perpendicular to the selvage. And warp and weft, they are at a angle 90 degrees it is there. So from this, so here what is called as, this is called as interlacement. Now there are various ways are there. Interlacement means, so whenever the interlacement is taking place, one warp, so warp will be one up, down, up, down, up, down. So that is called a plane view. Two up, one down means two up ends will be up position, one will be down. So that is called a twill fabric. Three up, one down means that is called as again drill fabric. Four up means these four warp ends are at a position weft is down. This one is down. So that is called a satin fabric. It is there. See, in detail, you are going to study in a fabric manufacturing. Don't worry. Just to give the idea. So whatever this thing it is there, this is called as warp, and this thing is called as weft. Clear? So this is the highest consumable fabric it is there, woven fabric. See, which we are using for the shirting, suiting, or whatever our dress material it is there, whatever our home textile means our bed sheets are there, pillow covers are there, curtain fabric it is there, whatever the fabric it is there. That particular fabric is a woven fabric it is there. Next, that is nothing but the knitted fabric. Knitted fabric, there are again, just like here we got the warp and weft. In knitted fabric, we got a well and the coast it is there. So it is difficult for me to show over here how the well and coast. But in one of the video, whatever the next video it is there, you can easily see the what is the well and the coast it is there. So which is the knitted fabric? See, whatever the our t-shirts are there. T-shirts. So fabric which are using for the t-shirt it is there. That is actually the knitted fabric it is there. Where we can have the well and the coast. So just like in one fabric, we got a warp weft, it is there. So warp, we got the continuous length, which you are going to get it from the beam. So next video, we can see over there, what is the warp and weft. Then next to that video, we can easily see the what is the well and the coast. That point I will show you. Then third category, the fabric that is nothing but the non-woven fabric it is there. And non-woven fabric, we are directly converting from the fibers. See, for woven and the knitted fabric, we got the fibers, yarns. From the yarn, we are going to get the woven fabric. We are going to get the knitted fabric. But whatever the non-woven fabric it is there, the non-woven fabric, we are going to get it from the fibers over there. To directly these fibers, we can convert to the fabric. And examples I told you that various type of the wipes, mask. These are the examples of the our non-woven fabric it is there. Clear? Clear these points? Any
Yes,
doubt
sir.
regard? Okay. Now see what I'm going to do. I am going to show you the 3 different videos. As here we are not one-to-one. So just have a look on this video. So first video is related to the woven fabric it is there. Just you have to tell me, are you in a position to see the video or not? Can you see the screen of the video?
Yes, sir.
Yes, sir.
Now
Yes,
video is
sir.
running. Can you see the video?
Yes, sir.
Yes, sir.
Video. Okay. So just have a look how the woven fabric is manufactured. Sorry. So, so these things are called a beam. From the warping, we are going to get the beam over here, and whatever the ends which are used the term. So this is a warp or the ends, both are same it is there. And these are loaded on a machine that is nothing but the loom it is there. So whatever the woven fabric which you are going to get for the woven fabric, the machine which you are using that is nothing but the loom it is there. So that might be our plain loom it is there, or settleless loom it is there. Whatever the, just like you might be heard our Sulzer, air jet, water jet looms. Hmm? These we are using for the manufacturing of the fabric it is there. Okay, so concept regarding the one fabric is clear to you? Yes, any one of you?
Yes, sir.
Okay.
Yes, sir.
Okay,
Yes,
okay.
sir.
Now next we'll move toward the next video, that is of the knitted fabric, how the knitted fabric is manufactured.
Knitting is defined as the intermeshing of yarn into loops to form fabric. There are different ways that yarn can be subjected to the needles for fabric formation. In knitting, there are basically two systems. These are weft and warp. What makes them different? Let's take a close look at each one. Weft knitting is accomplished.
See, there are in knitting also warp knitting and web knitting it is there. See, why I'm not going in details, because all these things in detail you are going to study in one more subject in a semester 2, that is the weaving and the knitting technology. So just to have the you idea, see how the fabric it is there. Means one fabric, knitted fabric, and the non-one fabric, this point is here.
By loops formed in a horizontal manner by adjacent needles. The most common machine used for weft knitting is the circular knitting machine. This machine creates a tube of fabric in a spiral configuration around a cylinder. The width of the fabric is determined by the number of needles on the machine. One revolution of the machine completes one course for each yarn fed. A second type of machine can be used to produce weft knit. This machine produces fabric on needle beds that are flat, so it's called a flatbed machine. Regardless of the type of machine used, in weft knitting, needles placed next to each other knit one after another in sequence to produce one row of loops from the same yarn. Here is an illustration of how loops of yarn are created by a weft knitting machine that knits yarn in a horizontal manner, so that the loops are formed from right to left. If you analyze the structure, you see a pattern of loops arranged in rows and columns. The horizontal row of loops, produced by adjacent needles during the same knitting cycle, is known as a course. The course count is measured by the number of courses per linear unit, expressed as inches or centimeters. If this drawing represents a 1 inch by 1 inch area, you identify this as 5 courses per inch. The vertical column of loops produced by the same needle knitting at successive knitting cycles is referred to as a wale. The wale count is measured by the number of wales per linear length. In this same drawing, there are 5 wales per inch. The second system used for knitting is produced by machines that are designed differently, to vertically knit. This illustration shows you how warp knitting, in contrast to weft knitting, is accomplished by forming loops in a vertical direction. If you look closely at an illustration of warp knit, you see that the yarn is intermeshed vertically with 2 wales. With warp knitting machines, each individual loop is created from separate lengthwise yarns. Wound onto a beam from yarn packages in a creel, the yarns arranged as a warp must be placed parallel to each other. Normally, for the most basic of fabrics, each yarn needs its own needle. If 1,000 needles are used on this machine, there needs to be a minimum of 1,000 warp yarns. If there is more than one yarn provided for each needle, more elaborate fabrics can be produced. With warp knitting, individual needles knit simultaneously across the width of the machine. Loops are formed by needles knitting a series of warp yarns fed vertically and parallel to the direction of the fabric formation. Warp knitting machines are typically used to produce tricot, rochelle, and crochet.
Okay, related to knitting is clear to you? Yes?
Yes, sir.
Okay.
Yes, sir.
Then,
Yes, sir.
Yes, sir.
okay. The next thing related to the non-woven fabric.
Imagine for a moment you're a product designer. It doesn't really matter what field. You might design shoes, or cars, or diapers, or furniture, or even spaceships. Chances are your product will use some kind of fabric, and that fabric is going to need some special qualities if it's going to perform properly. Qualities like absorbency, or elasticity, or strength, or flame retardance, or shock absorption, or some combination. Our product designers are simply inventing their dream material. Non-wovens are produced by a wide variety of manufacturers, including many leading Fortune 500 companies. In these fabrics, individual fibers are bound together not by weaving or knitting, but by other chemical, thermal, or mechanical means. By varying the processes and the raw material used, these carefully engineered fabrics can create some pretty remarkable advantages. Advantages that woven products often can't touch. They can be strong enough to use in constructing roads and roofs. They can be soft enough to protect our most delicate surfaces. They can be sandwiched together to create a fabric with layers that have different properties. They can be molded to a precise shape. They can make us feel both attractive and comfortable. Some can absorb several times their own weight in water, oil, or other fluids. They can filter out hazardous chemicals or dangerous bacteria. They can be made gossamer thin or extremely thick, dense, or porous. While woven products can be produced at only a few feet per minute, non-wovens can be manufactured economically at 1,000 or more feet per minute. They are so inexpensive that they're cost-effective as single-use products, but they can be durable enough to last for years. They can be sewn, heat-sealed, punched, and cut in any direction. They can be used as replacements for traditional textiles in almost any application. All these capabilities are carefully engineered into each fabric using a range of natural and synthetic materials and various bonding techniques. Non-wovens begin as loose web mattings that can be formed through several processes. In the dry lathe process, fibers are mechanically combed or carted into position. Or laid down by a controlled airstream. Or they can be transported by water, the wet lathe process. Then, the fibers are joined together by resin or fused by heat. Some are punched with thousands of needles to interlock the fibers, while others are meshed by high-velocity water jets. As an alternative, in the spun-bonded and melt-blown processes, resin pellets are melted, and the fibers blown against a moving surface to create a fabric in a single step. These processes create an incredible variety of fabrics. In fact, you'd probably be surprised at the many ways your life is touched by nonwovens. Non-woven absorbent products like baby diapers and sanitary napkins provide superior performance and convenience. Consumer wipes are one of the largest uses for non-woven fabrics. Industrial non-woven wipes are widely used to clean up in automotive, printing, and other plants. And these limited-use wipes create less pollution than cloth rags, which must be laundered. Using non-woven linings and pads, fashion designers give shape to their creative visions, while very different kinds of apparel protect workers from exposure to workplace hazards and shield sensitive products from contamination by humans. Medical products, such as operating room gowns and drapes, protect both caregivers and patients from infection. They provide a breathable...
So PP kits. So these are the PP kits which are manufactured by using the non-woven fabric.
barrier that transmits moisture vapor but not fluids, and they cost less per use than laundered products. Non-woven fabrics make excellent filters, capturing impurities and providing precise rates of flow in applications from auto air filters to industrial incinerators, from tea bags to vacuum cleaner bags. By the way, the carpeting can be a non-woven fabric too, just one of a growing number of tough, durable applications appreciated by homemakers, along with the furniture, drapes, and quilts that use non-woven components in homes around the world. Very few consumers fall asleep dreaming of non-wovens, but most do fall asleep on non-wovens, since up to 80% of mattresses use non-woven components. Non-woven's durability and moldability are important advantages for automotive trim fabrics such as carpets and hood and trunk liners. A special group of non-wovens called Textiles helps reduce the cracking in asphalt, controls erosion, and keeps our landfills safely sealed. Farmers use non-wovens to control weeds and conserve moisture for their crops, while roofers appreciate their strength and ability to withstand harsh conditions. And non-wovens are heroic performers at some of the toughest jobs imaginable, resisting flame, stopping bullets, and as part of the high-tech tiles in the outer skin of the space shuttle, bringing our astronauts safely back to Earth. Already incredibly versatile, non-wovens continue to evolve as product designers demand even more specialized fabrics, and as non-woven companies respond with new materials and manufacturing protection and beauty effectively and economically. They allow us to innovate, to prosper, to give flight to our imaginations.
Okay, so I think that things related to the non-woven is clear to you, which got a great potential in the future. We can use for the apparel wear, in a medical textile, in transportation textile, in automobile sector as a filters. So wide application area it is there. Clear the things regarding the non-woven fabric?
Yes, sir.
Okay.
Yes, sir.
So, okay. So today we'll stop here. Now, if you got any doubt, now the session is open for the discussion.